Welcome. In this video, we're going to talk about chemical and physical changes. So in a physical change, the chemical identity of the particles remains the same. And that's the focus I want you to have when you're thinking about a physical change. You might change the spacing, you might change the relative speed of those particles, but the identity of those particles stays the same. So if I look at a particle visualization, it'll look something perhaps like this. If you look at this image, it looks just like the pictures we were doing in our last unit for phase change. So this might represent a liquid turning into a gas, and that evaporation process changes the spacing of the particles, but the identity stays the same. So phase changes, melting, boiling, freezing, condensation, sublimation, all of those phase changes that we saw in the last unit, those are all examples of physical changes because you have the same material at the beginning and at the end. Other examples of physical change include things like tearing, breaking, cutting, crushing. All of those, you have the same material at the beginning and at the end. In a chemical change, you're actually changing the identity of the substance. So you start with one material and you end with a different one. This is fundamentally different. And I want you to use that definition, I have something new, to organize your thoughts about a chemical change as opposed to a physical change where the material is the same. So for a chemical change, the particle visualization would show that you've made something new. As you look at this particle visualization, you'll notice originally that every particle was made of a blue and a red particle that were attached, that were combined. So this was a compound. But then as the chemical change occurred, I ended up with something different. So now I've got blue particles separate from red particles. And so we have a different material. And that's the hallmark of a chemical change. So some examples of chemical change would include burning a substance, reacting it with acid, reacting it with oxygen, doing something that's going to change the identity, causing it to break down into its component parts, but you're going to change what that identity is. We can also talk about physical and chemical properties, and these relate very closely to the physical and chemical changes that we saw just a second ago. So a physical property is something that you can observe without having to change what the material is. So these are things like color, density, texture, mass. These are all physical properties. On the contrary, a chemical property, in order to observe it, you actually have to change what the material is. This is going to be things like flammability. Will it burn? Reactivity. So will it react with a particular chemical? Things like that. In order to do them, you actually have to change what the material is. Both chemical and physical properties can be classified as intensive or extensive. An intensive property is one that's independent of the size of your sample. So something like density or color or flammability. Those properties are going to hold true regardless of whether you have a large sample or a small sample. Extensive properties, on the other hand, are things that depend on size, like mass, volume, length, things like that, where if you change the sample size, you're actually going to have a different value for that property. So in sum, when you're talking about chemical changes or chemical properties, you're talking about things that are going to change the identity of what the compound is. Where physical properties and physical changes, the identity stays the same. And then for both of these properties can be classified as either intensive or extensive. Intensive is independent of sample size, and extensive properties do depend on the size of the sample.